Hey everyone, and welcome back to the Nova Protocol Devlog. In this update I finally added objectives, some basic enemy AI and gave the visuals a small upgrade. To make the game look a bit more appealing, I decided to start with improving the asteroids. They were just spheres with random colors, which is kind of boring. To change that I wanted to create some different shapes. At first I thought this would be a quick in and out trip to Blender, but it wasn't. I wasn't really satisfied with having a single rock model, even if it had different scale and textures, because it kind of looked the same. So I implemented procedurally generated asteroids. This was something I wanted to explore for a while, and I kind of let myself fall down into a rabbit hole. I remember one of Sebastian Lag's tutorials on procedurally generating a planet, and I decided to try out something similar. Sadly, I couldn't just copy-paste it, because the compiler wasn't happy with the C# code, but I tried to follow it as close as I could. First, I generated a sphere using an octahedron. Why? Well, because Sebastian said so, but all jokes aside, basic sphere wouldn't work because the vertices are not evenly distributed. On the other hand, an octahedron is made up of triangles that are roughly the same size, and they give you more control when we want to apply noise. To add some variation to the asteroids, I yoinked the noise generation code from my old game and slapped it on top of the planet. Okay, it didn't work first try because of some normal issues, but then I fixed that and it worked. Basically first try if you'd ask me. Then I took a picture of a rock, yes, I go outside, made it seamless and slapped it on top of the asteroid, and now we have a better looking sphere. The UVs are still a bit meh and the texture doesn't really match everywhere, but it's good enough to mark as complete for now. I'll just put a to do in the code to fix it later, and we all know that's not gonna happen. However, the game still felt empty. I mean, sure, editing a spaceship, flying around and shooting asteroids is fun for a while, but it's not a great game loop, if you'd ask me. I guess the easiest way to fix that was to give the player some tasks to do. Think of them as chores, but they're actually fun because you play a video game. So I added objectives. I could have made a couple of hard-coded levels, but I don't really like that. For some reason my brain was fixated on modding. I guess that's because when I was younger, I used to play a game called The Battle for Westnath, which is written in C++, but uses a very simple modding language for custom scenarios. And that idea kind of stuck with me, and I wanted to implement something similar in this game. Then after a bit of prototyping and mental struggle going through C++ code, I had something that kind of worked. Kind of. It's not really a standalone language yet, and right now it's just using Rust structures, but eventually I want to make a small DSL that gets parsed into those structures. Or maybe I'm just gonna use JSON or TOML. I don't know. Going full Lua level modding feels kind of overkill for now. And the system is quite simple. Events, filters and actions. Events fire from the game. For example, when an object is destroyed, we just trigger an onDestroy event. And we also pass the object's ID and type. If the scenario defines an event handler that matches that filter, we execute the action. So for instance, you could say, when an asteroid is destroyed, increase the player score. Right now the set of actions is tiny, but I'll add more as I need them. And yeah, I know this sounds a lot like the observer pattern, which already exists in Bevy, but I wanted something more data driven, something that I can literally just load from a file. And I guess, you cannot really load Rust functions from a file, but you can load structs and turn them into logic at runtime. Once that system worked, it was easy to make a few basic scenarios. Destroy some asteroids, take out an enemy ship, and then switch to the next mission depending on the outcome. It's simple, but it's the start of a real gameplay loop. And speaking of other spaceships, I finally added some enemy AI. Even if it's dumb and can't really beat a real player, it's better than nothing. The first enemy just tried to follow the player. I guess the logic was quite simple. Rotate to face the player, and if the alignment was good enough, thrust and shoot. But the AI didn't really understand the physics and just kept flying off into space like it had somewhere to go. Then I was curious how well ChatGPT would do writing an AI for the spaceship. Yeah, I don't know what I expected. The AI is still kind of trash, but at least now it doesn't fly off anymore because somehow it forgot how to use the thrusters. Okay, so one interesting problem that I noticed is actually target prediction. Right now the AI just points its turret straight at me, but because the projectiles inherit inertia and I'm also moving, it's going to miss. This isn't just an AI problem, it matters for player auto aim too. And I'm thinking to add some kind of predictive fire mode to make the turrets feel more like the expand style inspiration that I had originally. In the last devlog, we added projectiles. They were just cubes flying in a straight line. However, if the ship is moving while we are shooting, the bullets should inherit part of that velocity. You know, inertia in physics. You might think, yeah, easy, just add the ship's velocity to the projectile. And that's actually true. Except Baby had a different plan. See, in game dev we have this thing called a transform. This stores an object's local position and rotation, also scale, but you know, nobody cares about scale. And my turret has a transform, and it's parented to the spaceship, which also has a transform. And to spawn projectiles in the world, we actually need a global transform, which is basically the position and rotation in world space. And Baby gives you that, but it only updates it at the end of the frame. So that means that it's always going to be one frame behind the real position. And I guess I figured that wouldn't be a problem, but I was actually wrong. The problem, well, the physics engine runs in fixed update, and this schedule runs first in the frame, 0 or multiple times, until it, you know, catches up with the fixed frame rate that you set. And this can cause some weird sync issues with the transforms. The game looked really jittery and honestly unplayable. However, due to my great instinct of adding debugging to the game, I was able to figure out a solution that made the game much smoother. I guess as counterintuitive as it sounds, I first disabled interpolation. Somehow interpolation of the transform made everything worse. And I know, I was surprised too. It's supposed to smooth things out in between the frames, but in my case, the jitter was worse with interpolation enabled. Then I moved most of my logic into the post update, which, as the name suggests, runs after the update schedule. And that way the inputs are collected first, and then the logic runs after. And I guess Baby's own docs actually recommend using post update for systems that the player doesn't really care about, which fit my case perfectly. Obviously, I didn't move everything to post update. It was mainly the stuff that I want to reuse in other projects as well, which makes more sense if you would look at the code. I guess you can check it in the description if you really wanted to, but you'd have to trust me on that. And finally, for world position, which might be actually the thing that matters the most, I manually calculated the global transform when needed. So I actually didn't have to rely on Baby to compute the transform for me at the end of the frame. Even if that means it's gonna be done twice, which makes it more expensive, I'm only doing it when I'm firing projectiles. So it's not gonna be a big deal unless you fire projectiles on every frame, which even then you won't really notice it in the frame rate, so I guess it's fine. And as I maybe already hinted, something that really helped me during this entire implementation was the debugging setup. Before I started to work on the new version, I was just like eyeballing the physics and I was hoping for the best, but that's not ideal. So I added a few debug menus and a couple of UI elements to actually see what the physics was doing instead of just guessing. Also, I added a status bar item, which is, yeah, a little bit over engineered. It shows the FPS and version info, which is pretty normal stuff, but it can also literally run shell commands and display their output. So technically I could have it run uname and show the kernel version from inside the game, because reasons. Then I made a super debug mode. It disables all the nice graphics, shows all the system sets in a graphics graph, and lets me check if everything runs in the order that I expect. This was really helpful in debugging the physics set issues. And an honorable mention goes to the great refactor of Doom. When I started working on the new version, my main.rs file had grown to almost 2000 lines. So I told myself, alright, time to refactor. I moved stuff around, hated it, moved it again, hated it again, and yeah, that went on for way too long. And I always tell myself, don't refactor during the prototype phase. And then I immediately refactor, every time. I think I just do it too early, before I even know what the game needs. But I still try to keep things as simple as possible. I really don't like when a library hides something as simple as how to do 1 + 1 under 10 files and 5 design patterns. That kind of stuff makes me want to avoid dependencies completely. So yeah, after like 10 years of coding, my advice is probably one giant main file that does everything might not be pretty, but hey, at least it's easy to follow. Still, I think there should be like a better balance between yandere dev, or how cool kids say it nowadays, pirate software, and an over-engineered solution. So anyway, it might feel like a waste of time, but now I can just reuse these systems in future projects. Just copy paste and go. That is something that I started to appreciate more and more. So maybe it was worth it. That's version 0.2 so far. We've got objectives, basic enemy AI, a better debug system, and some nice asteroid visuals. Next up, I'll probably focus on polishing combat, improving visuals, and making the AI a bit smarter. If you enjoyed this update, leave a like or tell me what kind of objectives or enemy behaviors you'd like to see next. Thanks for watching, and I'll see you in the next one. So until then, see you.